Hi everyone, in this video I'm going to teach you how to graph systems of linear inequalities. Let's start with some key concepts. A system of inequalities is two or more inequalities in the same variables that work together. The solution to a system of linear inequalities is the set of all points that make all the inequalities in the system true. The third one that we need to understand is that the solution region is the intersection of the half planes of the inequalities where they overlap. That's the darker shaded region. Later on, you will better understand what key concepts, what are these key concepts when I teach you how to graph the systems of linear inequalities. So let's start by the steps. So what are the steps? Step number one, graph the first inequality as a linear equation. But here, what I will do is I will utilize um the y equals mx plus b. So we will convert each quadratic, or sorry, each linear inequality into y equals mx plus b. And then we will use a solid line for inclusive if you see like an equal sign of the greater than or the less than symbol. And then we will use a dash line for the non-inclusive. Shade the half plane of the y-intercept, above the y-intercept rather, for greater than, and shade the half plane below the y-intercept for less than. Okay? Follow steps number 1 and 2 for the second inequality. The overlap of the two shaded regions represents the solutions to the system of inequalities. And the last step is check your answers by picking a test point from the solutions region. That's the overlapping region. So if you get the true statement both correct, then both inequalities, then your answer is correct. Okay, so let's begin with this example. I have three examples here, so hopefully you will learn how to graph systems of linear inequalities. So let's start with x minus y is less than 2. So you have x minus y is less than 2. A while ago, I told you that the first thing we will do is we will convert into each inequality into y equals mx plus b, because to graph both, what I will use is just identify the slope and the y-intercept. Slope and the y-intercept. Okay. So here, so we will need to move everything to the right side, right? So I will subtract x on both sides. This will be negative y is less than negative x plus 2. Now here, we want the y to be positive, right? So we will divide each term by negative 1. So we cross that out. Now, when we divide a negative number in an inequality, the inequality symbol will change. Okay, meaning if it's less than, it will be greater than. If it's greater than and you divide it or multiply a negative number, it will change from greater than. If it's greater than, it will be less than. If it's less than, it will be greater than. So x minus 2. And then what I will do here is I will find the slope. So here I will make the slope, the numerical coefficient of x, that's our slope. I know it's 1, but I will do 1 over 1. Okay, later on you will understand why I have 1 over 1. And then the y-intercept is at 0 and negative 2. Okay, so now using the slope and the y-intercept, what we will do is we will graph that. Let's start with the y-intercept. So we will locate 0 and negative 2. So it's here. And then what I will do is I need to create another point using the slope. So our slope is 1 over 1. That means for the numerator 1, that means 1 unit upward. For the numerator positive 1, that means 1 unit to the right side. So 1 unit up, 1 unit to the right side. So 1 unit up, 1 unit to the right side. And there you go. That's your other point. So now that we only need 2 points. So now that we have these 2 points, we just need to connect them using a dash line because it's a non-inclusive inequality. So dash line. There you go. And then I will shade the since it's greater than now, right? The reference here is the y equals mx plus b form. That's greater than symbol. So we will shade the upper region of this um, inequality. So let me use the yellow green there. Okay, there. Okay. Okay, next. Let's have the second example, or the second inequality rather. We have x plus 3y is less than or equal to 6. And the objective is to find or to transform that into y equals mx plus b. So I will subtract x on both sides. This will be 3y is less than or equal to negative x plus 6. Then we need to divide each term by positive 3. So y is less than or equal to negative x over 3 plus positive 2. Okay, so our slope here is negative 1 over 3. So whatever the numerical coefficient of x, and our y-intercept is at 0 and 2. So we will begin with the y-intercept, which is 0 and 2, and that's here. And then from there, we just need to use the slope to find the other point. So that's negative 1. That means 1 unit downward. And then our denominator is 3. That means 3 units to the right side. So 1 unit down, 3 units to the right. There's our point. And the line that we will use here is a solid straight line because we have an inclusive inequality. There you go. Okay. So for the shading part, since it's less than, we will shade the lower region of this inequality, which is this region right here. There. Now the overlapping region of those two is the region of our solution. So that means all the numbers there should satisfy both the inequalities. I'm talking about this, the overlapping region. Okay, so that's the solution. So whatever points we have there will make both of the inequalities correct. And let's try 1 point. Let's try 0, 0. Okay, so 0 here, let's try the first inequality here. So if you replace 0, 0 there, so 0 minus 2 is negative 2, and then get 0. Is 0 greater than negative 2? Yes. Here, 0 is less than or equal to negative 0 over 3. So that's 0 plus 2, that's 2. So is 0 less than or equal to negative 2? Oh, positive 2? Yes. So you're absolutely correct. Let's go to the next one. I have 3 here. So let's make this quick. As long as you understand the procedure, so that's good, right? So we have 2x plus y is greater than 2. I'm going to subtract 2x on both sides because we will convert this or transform this into y equals mx plus b. That's what we want. And then now we have y is less than negative 2x plus 2. So our slope here is, I will write negative 2 over 1. Okay. And then the y-intercept is at 0 and 2. We will start with the y-intercept 0 and 2. So now since it's negative 2 over 1, it means 2 units down. Oh, 2 units down. And then 1 unit to the right side. And there's your other point. Now connect those 2 points using a dashed line. Oh, that's not dash. For a non-inclusive inequality, because it's just less, it's just greater than. And then for the shading part, we will show the upper region of the upper side of this line because it's greater than, right? So here. Okay. Let's answer the second one. So x minus y is less than or equal to 3. Subtract x on both sides. This will be negative y is greater than or equal to negative x plus 3. And then we need to divide each term by negative 1. Y, now this will become less than now because we divided a negative sign, right? Or a negative 1. This is x minus 3. Our slope is, I will emphasize, it's 1 over 1. And now the reason why I'm doing that is because I don't want you to I want you to remember that we have the movement of vertical movement and horizontal movement. Okay, so 0 and negative 3. So 0 and negative 3 is right here. That's 1 over 1. So that means 1 unit up, 1 unit to the right side. Here's your other point. So here I will use a solid straight line. And then for the shading part, we have a less than symbol here. So that means I will shade the lower side, lower region of the line. There you go. The overlapping region is the solution, and you just need to emphasize that. There. This. There you go. Let's go to the last example. Again, first thing we need to do is to convert into y equals mx plus b. So for the first inequality, we got negative x, cross that out. This is negative 2y is greater than negative x plus 4. And then we will divide negative 2 on both sides. Negative 2, negative 2. Cross that out, so y is less than x over 2 minus 2. Again, every time you divide a negative number or multiply a negative number in an inequality, the inequality symbol will change. From if it's greater than, it will become less than. If it's less than, it will become greater than. So our slope here is 1/2, and the y-intercept is at 0, negative 2. We will start with the y-intercept, and then from there, use the slope to find the other point. So that's 1 unit up, 2 units to the right side. There's your other point. And again, we will use a dashed line here because it's non-inclusive inequality. And then we will shade the lower region because it's less than. There you go. Now let's do the next inequality. X plus 4y is greater than or equal to 2. And then I will subtract x on both sides. This negative x plus 2. And then 4, no, divided by 4, divided by 4, divided by 4. So 4 is greater than or equal to, not 4, y is greater than or equal to negative x over 4 plus 1/2. So our slope here is negative 1 over 4, and our y-intercept is at 0 and 1/2. 0 and 1/2 is right here. And then that means negative 1 unit up, it's here. And then 4 units to the right side, so 1, 2, 3, 4. There's your other point. And then the shape, oh no, we need to connect the 2 points. Oh, sorry. Wait. Made a mistake again. It's -1, so 1 unit down. 1 unit down. That's why I felt there's something wrong. And then 4 units to the right side. There. Okay. I was like, there's something wrong here. So now there, I already fixed it. So -1, the movement is 1 unit downward, and then 4 units to the right side. So connect the two points using a solid straight line, and then shade the what part, what region, the upper region. Let's use this one. There you go. And then I'm going to emphasize the here, the intersection. There you go. So that's how you graph systems of linear inequalities. I hope you learned something. Thank you. See you in my next video. Have a nice day. Bye bye.